Hi everyone. This video is going to be discussing the idea of continuous random variables and probability density functions. So just as a quick recap, here's an example of a binomial distribution. In this case, I have set the probability to 0.5 and I can change the number of trials in this binomial experiment up to 200. When I have 200 as the number of trials, you can see that this is fairly smooth. Each of these little histogram blocks is very, very thin, and this is getting close to a nice smooth curve. If I was to reduce the number of trials, for instance, say back to something like this, then, well, it's definitely a lot bigger steps in between each of these individual events, and it's no longer looking smooth and continuous, it's definitely discrete. Well, I mean, even this one is discrete, but the steps are getting so small that it's a very small change from one to the next. We could imagine doing many trials where the steps are so small that it virtually becomes a nice smooth curve, and that's what we call a continuous random variable instead of this, which is a discrete random variable. So let's define the idea of a continuous random variable where we have some function that behaves like this. Now this would be the x-axis and this would be our function. As long as our function never went below the axis, that would be okay because probabilities can never be negative. And the other thing that we would have to remember, of course, is that the area under the function represents all the possible outcomes, and so that would be a probability of 1. So the integral from point A to point B, where this is some point A and this is the end of the function here at point B, of our function must equal 1 to represent all the probabilities. If those two conditions were met, then this thing is a probability density function. Let's take a look at a couple of examples. For instance, if I had the function let's think of a function. What if I have a function of x which is 2 times x times 1 and x belongs to the interval 1, 2. If I let this be continuous, it wouldn't work. So is this thing a probability density function? Well, let's do a quick sketch. I would need an x value and I would need the function f of x. So x is only allowed to start at 1 and go to 2. If x does equal 1, then 1 take 1 is nothing, 2 times nothing is nothing. So the value of the function there is 0. And then if x equals 2, 2 take 1 is 2. What do I say? 2 take 1 is 1, 1 times 2 is 2. So multiply that would be up there in line with 2. And it's continuous, so there's a straight line across there. Now, it stops at that point. The function does not go any further. So is it positive? Yes. F of x is greater than or equal to 0 for the entire domain. Tick. Now what about the area? Well, this is a triangle. The base of the triangle is 1, the height of the triangle is 2. I think you can work out that the area being a half times the base times the height is 1. But we really probably should integrate from 1 to 2, the limits of the function, of our function, 2x take 1 dx. Let's do this integral. So the constant 2 can come to the front of the integration. There's the integral of x take 1 dx. Integral of x is x squared over 2 minus integral of 1 is x. And the limits of integration were 1 and 2. So substituting 2 here, 2 squared is 4 over 2 minus 2. 1 squared is 1 over 2 minus 1. Well, 4 over 2 is 2. 2 take 2 is nothing. 1/2 minus 1/2 is negative 1/2, and it was subtract negative 1/2. I hope we can see that that is 2 times positive 1/2. That equals 1. And that's exactly what it needed to be. So the integral, the area, equals 1. Give that a big tick. This thing is a probability density function. This statement here, that represents a probability density function because it meets the two criteria. The criteria being that the function is equal to or greater than 0 across the domain, and that the area underneath the function equals 1. That's lovely. What if we try a slightly different one? What if we tried, here's a nice idea. What if we try this one? F of x equals 2x cubed, and the domain x is from the interval 1, negative 1. So we start with a sketch. X can be negative 1 to positive 1. What if we go negative 1? Negative 1 cubed is negative 1 multiplied by 2. That would be negative 2. I think we're in trouble already because the function is negative. If x was 0, 0 cubed is nothing. And if x were 1, 1 cubed is 1 times 2 would be up here to 2. I think this function, being a cubic, would be a curved function like this. Straight away, we can say this fails the test because our function of x is less than or equal to 0, at least for some parts of the domain, which means it can't represent probabilities. So there's one that is not a probability density function, whereas this one back here, it worked nicely. It definitely is a probability density function for a continuous random variable. Thanks for watching.